Hello, good afternoon. We are the Team B, and we are made up of Mariana Gaitan, Alejandra Luna, Efraín Moreno, and me, Aldo Rivera. Well, today we are going to present our final project, which consists of a logistic model of a dataset about diabetes disease. Well, diabetes is undoubtedly one of the most important health problems in the world, with about 240 million diabetics on the planet. It is also estimated that half of those affected are unaware of their situation because they suffer from it to a mild degree, and that about 40% of overweight people suffer diabetes without knowing it. Worldwide, it's increasing due to population growth, age, urbanization, and the increase in the prevalence of obesity and physical inactivity. This project details an analysis of the database from Kale website, which is a free platform that offers users a series of problems to solve with topics such as data science, predictive analysis, and machine learning. This dataset is originally from National Institute of Diabetes and Disease, Digestive and Renal, and the contents were taken from the hospital Frankfurt, Germany. Well, in addition, this project is aimed mainly at research and health personnel who can contribute and help solve problems related to diabetes. That is why we have given ourselves the task of creating an alternative to reduce the figures through the estimation and classification of data through logistic regression, the dependence association of some variables, and the diagnosis of people with this disease.
The logistic regression algorithm is one of the most used today in machine learning. Its main application being binary classification problems. It is a simple algorithm in which you can easily interpret the results obtained and identify why one result or another is obtained. Despite its simplicity, it works well in many applications and is used as a performance benchmark. Logistic regression measures the relationship between the dependent variable, the statement to be predicted, with one or more independent variables, the set of characteristics available for the model. To do this, it uses a logistic function that determines the probability of the dependent variable. Given the logistic regression is a method for classification problems in which a binary value between 0 and 1 is obtained, an outcome is the variable that determines whether the patient has diabetes or not. The analysis used for this project is logistic regression. The database has the information of 596 patients, some of them diagnosed with diabetes and others not. To perform this logistic regression analysis, 211 of the 596 data were taken to make the model, while the remaining 384 were used to perform the classification and to estimate the error data. A logistic model was carried out to model the relationship between the set of possible predictive variables to be able to make a diagnosis of diabetes and a response that in this case will be having or not having diabetes.
Hypothesis test. Hypothesis null. The coefficient of the term is equal to 0, which implies that there is not association between the term and the answer. And the alternative hypothesis, the coefficient of the term is different from 0, which implies that there is an association between the term and the answer. With a significance level of 0.05, for glucose and BMI terms, the p-values are lower than alpha, which indicates that the association is statistically significant, while from the terms number of pregnancies, insulin levels, age, pedigree diabetes, blood pressure, skin thickness, insulin figures, ID, and split, the p-value is greater than alpha, since the association is not statistically significant, when it cannot conclude that there is an statistically significant association between the responses and the variable and the term. The model. It can be seen that from the sample, 76 patients were correctly classified as negative diagnosis for diabetes, and 81 were correctly classified as positive diagnosis. Of all patients, 157 out of a total of 384 were correctly classified. The error rate is 40.88%, and the hit rate is 59.11%.
Conclusions. In this course, we learn to carry out tests and statistical models whose with non-distribution or which don't conform to some non-distribution. We also learn to apply different methods and non-parametric models to solve real problems applied in the industry. In this project, we focused on the medical area by analyzing a database which compared information on patients with diabetes such database handled variables such as glucose level, insulin levels, number of pregnancies, body mass index, age, thickness, skin, etc. At the time of carrying out the logistic model to find the relationship between the possible predictive variables to make a positive diagnosis of diabetes and answer that in this case will be if you have diabetes or not. It was concluded that the variables that are most related to the target result of our analysis is body mass index and blood glucose level.